Good morning, children. We are continuing with the chapter sets, and this is the second part of this chapter. In the previous session, I have explained you what is a set. So, children, a set is a collection of well-defined objects. Then I have explained you that sets can be specified by different methods like the description method, rooster method, and the set builder method. Today I will tell you about the types of sets. Children, there are different types of sets. The first one is the finite set. A set whose members can be counted. So set in which you can count the members, that set is known as a finite set. That means in finite set the counting comes to an end. That means the elements which are present in the set can be counted. Suppose one example I have taken here, A. This is a set A, that is, and the elements in this set A are A, E, I, O, U. So 5 elements are there. So this counting is there, and now counting has come to an end. So this is a finite set. Number 2, the set of all persons on the earth. We can count the number of persons which are present on the earth. Then third one is B, set B, x such that x is equal to 2n. And this n belongs to a natural number. See, n, this n, and this n belongs to a natural number. So this n is a natural number. So 2 multiplied by a natural number, and this natural number is less than or equal to 30. So we can use here the numbers which are less than and equal to 30. We can take 2 into 1 is equal to 2. Then 2 into 2 is equal to 4. Like this we can take till we get 30. That is, n is less than or equal to 30. Next one is the infinite set. A set which contains unlimited members of the elements. A set which contains unlimited members or elements. That means the members or the elements, they are unlimited. That means they have no counting. That means the counting does not come to an end. So unlimited members we can say. Example is here the set of prime numbers. See, set of prime numbers, it is not limited. Prime numbers till 20, or prime numbers between 1 and 50, or prime numbers between 1 and 100. It is not mentioned particularly, but here it is given the set of prime numbers. So the prime numbers will continue to increase. There is no end. So no counting is there. The counting will not come to an end. So it has unlimited prime numbers. So this is an infinite set. Then the set of integers less than 0. Less than 0. All the negative numbers are less than 0. So there is no end. So we can say that this is an infinite set. The set of points on a line segment. See, on a line segment there are unlimited points, no end. So the counting does not come to an end. So this is an infinite set. So in finite set, children, the counting comes to an end. That means there are limited members are there which we can count. But in infinite sets, the members are unlimited. That means the counting does not come to an end, or we can say we cannot count the numbers. Then the third type of set is the singleton set. As the name is here, singleton means single. A set containing only one element. If a set has only one element, then it is known as a singleton set. Singleton means only one element is present in this set. For example, set A has only one element, that is 5. So it is a singleton set. Then set B has only again one element, that is A. So it is also a singleton set. Singleton set means it contains only one element. The next type of set is the empty or the null set. See, empty set is also called by the name of null set. So empty or null both are same. The set containing no elements. See, the set without any element is called empty set. So a set without any element. If there is no element present in the set, then it is known as an empty set or the null set. It is denoted by the symbol. See, you can see here the bracket, nothing, no element is here. If any single element is here, then inside it, then it is known as a singleton set. But here you can see the set is empty. There is nothing inside it. So it can be denoted by this or by the symbol, this one. This is also the symbol or sign of empty set or null set. This way also you can denote. That means it is an empty set. For example, the empty set is equal to people in a class over 70 years. See, there are no students in the class whose age is over 70 years old. So no such type of sets are present. Another one, squares with 5 sides. Is there any square with 5 sides, children? No. A square has only 4 sides. But here it is written a square with 5 sides. So we cannot say that it is a set. It is an empty set. So in the same way, children, next one is equal set. Equal. Equal means equal numbers. Two sets A and B are said to be identical or equal. Identical, you know, Xerox copy we can say. Same to same. Identical or equal, written as A is equal to B when they have exactly the same elements. Children, equal sets are also known as identical sets. We say that two people are identical. Identical means they are same to same or they are the Xerox copy. So a set A and B are said to be identical or equal, written as A is equal to B when they have exactly the same elements. If set A and set B, both of them, they have the same elements, then we say that it is an equal set. Set A is equal to A, B, C. So one element is A, another element is B, and another element is C. In set B also, see, B is here, C is here, A is here, B is here. That means all A, B, C which is present in set A is also present in set B, A, B and C. Understood, children? They are exactly the same elements, even though the number of elements are more here in this, but here 3 are there elements, here 4 elements are there, but all these 3 elements here and these 4 elements here are same to same. A is here, A is here, B is here, B is here. You can see C is here, C is here. So exactly they have the same elements. So it is known as an equal set. See, in equal set, even though the number may vary, but they have the same elements. Now the next type of set is the equivalent set. Equivalent set means if two sets contain the same number of elements which may not be exactly the same element. So equivalent set means even though the elements are not same, but they are same in their counting. If in set A 3 elements are there, in set B also they will have the 3 elements. But they are not exactly same elements. In equal set, the elements are same even though their number may vary. But in equivalent set, their number of the elements in both the sets will be same even though the members are not exactly same. One example I have taken here, see, in set A we have A, B and C elements, and in B set I have 1, 2 and 3. See, both these elements are totally different. Here ABC is here, in set B 1, 2, 3 is here. So both of them, they are different, elements are different, but in counting they are equal. 1, 2, 3, 1, 2, 3. So 3 elements are present in both the set A and B, and such type of set is known as an equivalent set. Now the next type of set is the disjoint set. Disjoint, that means they are not joined together. They are separate from each other. Disjoint sets. Sets which do not contain any element in common. Such type of sets are called disjoint set. That means set A has different elements and set B will also have different elements. That means they do not have any element in common. See here, example, set A has 1, 2 and 4 elements. Set B has 5, 6, 7 and 8. See, no element is same. Here 1, 2, 4 is here and here 5, 6, 7, 8. There is no common element in set A and B, and if the sets are having, two sets are having no common element, then this set is known as a disjoint set. Next type, that is the eighth type of set, is the overlapping set. Overlapping means they will overlap on one another. Two sets are called overlapping sets if they have at least one element in common. So in disjoint set we have no element in common, but in overlapping set we have at least one element in common. So it will be clear from the example. Set A has A, B, C, D as elements, and set B has A, E, I, O, U as elements. So the common element in both the set is A. Only A is common in both the sets. So one element we have in common. So this is an overlapping set. As it is written here, they have at least one element in common. If at least one element is there in common, then it is known as an overlapping set. One more example I have taken. Here set A has 1, 2, 3, 4, 5 and 6 elements, and set B has 3, 4, 5, 6, 7, 8. Now you can see the common element. This is 3. This is also 3. One element is common. Then 4 is here. 4. Second element is common. 5 is here. 5 is here. Third element is in common. 6 is here. 6 is here. 6 is also common. So here 1, 2, 3, 4. 4 elements are common in this, and here in this set I have shown one element, that is A, is common. So if any set has at least one element in common, then it is known as an overlapping set. This is the next type of set, is the universal set. Universe, the whole universe. That means everything is there in that set. Universal set. A universal set is the set of elements from which elements may be chosen to form the set. In a universal set, children, universal set is a set of elements. Many elements are written in universal set, and from that we make a set. Suppose, one example I will tell you. Suppose a universal set is there, all the alphabets from A to Z. And from that universal set, now I will make set A is equal to ABCD. Then I will form another set B, PQR, in this way. from the universal set, I have formed other sets. It is denoted by the letter C, this E, universal. This is the letter by which we denote the universal set. The symbol U is also used to denote the universal set. So U is used to denote the universal set. Example, the set of the letters of the alphabets is the universal set from which the letters of any word may be chosen to form a set. So, universal set will be the alphabets, and from which the letters of any word may be chosen to form a set. So, there are 9 types of set. Now about the cardinal number of a set. What is a cardinal number? The number of distinct elements in a finite set. Finite set means we can count the elements present in the set, is called the cardinal number. So, the elements which are present in the set, which we can count, such numbers are known as the cardinal numbers of a set. For example, you can see here in this A, 1, 2, 3, 4, 5, 6. How many elements are there? 6 elements are there. See here in this set A, B, C, D. How many elements? 1, 2, 3, 4 elements. We can count. So this 4 is the cardinal number. So example, I have written here A is equal to 1, 2, 3. See, this is the N. This is the cardinal A. Cardinal A. So cardinal A means how many numbers are here in this? 3. So cardinal A is equal to 3. That means in set A, 3 elements are present, which is written like this. Cardinal A is equal to 3. Second example is H, prime numbers less than 6. Set H has prime numbers less than 6. Now first we will write the prime numbers less than 6. H is equal to 2 is the least prime number, 2, 3, 5. These 3 prime numbers are there less than 6. So cardinal H is equal to 3. If here it is written prime number less than 10. If it is written 10 here. So the prime numbers are maybe 2, 3, 5 and 7 less than. So cardinal number may be 4. So in this way, children, cardinal numbers are written. So here we end this session. Thank you.